Welcome, everybody, to Barcelona, my favorite city in the world. I'm always super happy to speak here. And if you travel from somewhere else, you were very smart because it's super warm here. I come from Finland, so I was freezing. This talk is about software architecture because DevOps, Dev part, I'm Dev. But I have been working in the Dev community for, oh, my thingy is not thinking. Let's see. Now it's thinking. I have been a developer for around 20 years. I know I look young, but makeup does magic. And I started very young. And I was a developer that didn't care about anything, just coding, because that was my job. Then I got into the cloud, and I learned good DevOps practices. So that's why I love serverless, because it empowers me to do a lot of the things right, building things infrastructure as code, owning my own piece of shit, and I hope they're not recording this thing, and being able to deploy whenever I want, controlling my deployment pipeline. So I have been doing that now for many years. I'm the host of a YouTube channel, so if you like to see how to do serverless right as a developer, owning all your DevOps practices, you should check it out. And if you're a Spanish speaker, you should check my podcast, Charlas Técnicas, where the next episode is Ara. So if you were in the previous talk where she was talking about Kubernetes, she's coming. Let's see. Yes. Where she's coming next week to chat with me about observability in containers. And in the last week episode, we have something about event-driven architectures. That is the talk for me today. If you want to know everything, just follow me on Twitter. And this clicker is not clicking, so he was right. I might need to come here. Yeah, there. So I divide this talk into different problems, because that's what drives us to do things in Word. The first problem is how to coordinate tasks. And I'm not talking about containers here. I'm talking about software architecture. So when I started coding a million years ago, there was these solid principles. I don't know if you're familiar with them. Are you old enough that you heard about the solid? Good, one hand there. Thank you for sharing my age. And I love the solid principles because they have quite good software architecture things in place. And one of it is the single responsibility principle. That means that one class should do one thing. Now, if we take it to the functional world, one function should do one thing, and so on. So I keep that principle in my heart, because one function doing one thing means that it's easy to test, and it's easy to deploy, and it's cheaper to run. So if we want to build an application where I want to book a vacation to the Grand Canyon, so I book the hotel, I book the car, I book the flight, but I want to unwind everything if the car doesn't fly. Well, the car won't fly, but, well, you get the picture. How I do it? So the Marcia that was building when it started, object-oriented programming will make a very, very big method, and will throw things inside. It will say, if book, hotel, OK, then book car, then book flight, and everything will be totally coupled, intertwined, and very hard to test. Have you faced something like that in your life? I'm pretty sure you have. Yes, you have, and you're terrified of it. Then Marcia evolved a little bit and learned functional programming. Not serverless yet. This is just functional programming, where I learned that functions should not have side effects and should do one thing and one thing only. So I start building applications like that. Yay! But how you make them talk to each other? So I have to start calling functions. And then I found a problem, like my functions are stateless, how I start handling the state, how I handle the errors, how I handle the retries. It got very nasty at the end, because somebody has to handle the state. Then Marcia learned about queues and distributed systems. And it started to throwing things in queues, because those are cool. And we started in the serverless world. Let's throw things, let's make functions that are small, deploy them in the cloud, and throw events into queues. Yay! How I unwind for this, how I handle errors, how I handle order, how I handle my retries. Everything is decoupled, yes. Everything is quite testable, yes. But in some place, the state needs to be. So we end up having a database that is holding all the state. And then we need to keep track of who is touching that database and keeping track of that. And it becomes very complex. So that's where we talk about task coordination. Just to understand the pain, I want to order things. I want to do A, B, C in order. I want to retry things. Something failed, I want to retry. And I want to do exponential back-off retry so I don't kill my downstream services. I might want to do try, catch, finally. How you do that if you are not using a big fat ass method? I want to run a map reduce with my functions and then control the result in one single point at the end. How I do that? How I do if else or whatever conditional switches in my applications if I don't do a very big fat method. How I run tasks in parallel. Like I can optimize, sure, I can do that, but how I do it in a way that is easy to control. That's where the concept of orchestration comes into place. The orchestration is this type of thing where we have a master of ceremony that is telling all the different instruments what to do. The orchestrator has the state. The orchestrator knows what everybody needs to do. That's what I like to represent it with the orchestra, because the orchestra man is the one that is telling everybody what to do and when. In the case of services, we have a state machine. That is the one that contains the states and the order and is sending the information around. So if you have studied some computer science, maybe you have looked at state machines. They're a very old concept in most of any engineering. Why? Because they're so easy to think about. Our brain likes them. Basically, discrete states, functions. One starting state and some active states. One active state, or many if we have a parallel execution. States receive inputs, do something, and produce outputs. They're stateless functions. And then we have a transition based on the inputs and some rules we do. State machines. Lovely. We can do that with multiple libraries. We can do that with building it ourselves, or we can use the cloud. If you're in AWS, you can use the step functions. Step functions is the service from AWS that allows you to build state machines. You can define your flows, you can integrate with other AWS services, you can audit the executions, and do all kinds of things. So how step functions work? Well, state functions are state machines where you have states. Each state is a task into some service. You have transitions that you define your state machine, and you can reutilize those tasks. For example, you build a function, and you want to use it in other places, you can, because your function is doing one thing and one thing only. It's stateless, it has inputs, it has outputs. It has integrations with many services from AWS totally natively, so you can call Lambda, our serverless functions, you can call containers, you can call batch, you can call Dynamo, it's free, these type of services that we use a lot. And it also integrates with almost everything in AWS that has an API. So you can do quite interesting things. You can call our visual APIs. You can call our artificial intelligence API to translate, to transcribe. I'm dyslexic, so I have created a super simple workflow that took me like 2 seconds, that in a UI, I can just throw a document, and I get an email that it just transcribe it, so I can listen to it, so I can figure out if what I'm writing makes sense, because reading is hard. And that took me like half an hour to implement. I'm using a call to the service that does the transcribe, and it's used some poly service that is transcribing it in an English that sounds very English and very nice. And I can hear if I misscribe something or I use some word that is not right. You can define that as infrastructure as code. We are AWS. We love infrastructure as code. For the state machines, you can use the Amazon state language. That is our proprietary language for defining state machines. You can build them with CDK. You can build with the data science SDK. But everything at the end will transpile into Amazon state language. From your IDE, you can visualize those state machines while you're working on them. So if you get the plugin, for example, for Visual Studio Code for the AWS, you can visualize those state machines, or you can do it from the console. And then when you run those state machines, you can see every input and output for every state. So everything is auditable, and you can see to the grain what is going on. You can see all the executions, and you can filter, and you can process them, and you can understand and debug. If you don't like to code, or you are getting started, you can use the Workflow Studio, in my opinion, one of the neatest UIs that we have in the AWS console, where you just throw boxes into your state machine and you build it. And the cool thing for this is that it builds the infrastructure as code. It builds everything at Amazon state language. So then you can just import it into your project and use it as code so you can deploy it in multiple environments. We all want that. So in that sense, this is a cool tool because you can basically build the bare bones and then start adding all the different resources from your AWS infrastructure that you need. So let's go one more step. Now we want to build an example where we want to make a thumbnail. We want to identify some features from an image and store the metadata. So we upload an image to S3, our object storage, and we want to do all those things. How we do it with step functions? Very simple. We build a state. 8 states. Each state does one thing and one thing only. First state is a lambda function that will get what type of image it is. It's a JPEG, it's a PNG, it's an MP4. Maybe if it's an MP4, this is not an image, and we just don't do anything. The second state is a choice state. This state will analyze the input, basically what kind of image it is, and will decide which path to flow. It is an image or it's not. Then we are calling directly DynamoDB. And here we are storing that image metadata that we extracted from the image. And here we are running a parallel, 2 branches at the same time, where we have the Amazon recognition to get all the features of the image. This is a Bare Visual API. And at the same time, we are using Lambda function to create the thumbnail and store it in S3. When both branches finish, boom, the state machine is done. Challenge number 2. How to decouple microservices? And you might be thinking, but microservices are already decoupled. Wait a second. Well, we all have worked with monoliths, I imagine. Some way or another, you're not that young that you were born yesterday. So we all have been working with monoliths. Even startups always start with monoliths. And in some point of their life, they always have the same thing. OK, now I need to deploy this thing. I go to production. I cannot deploy it because somebody in some team went home and make all their tests. They're red. I don't know how to fix them. And my deployment is stuck. Yeah. Also, if we want to scale, we need to scale the whole thing. So we know monoliths are not fun. So we go back to the solid principle. Let's split it in things that do one thing and one thing only, microservices. Awesome. Now we can scale and we can deploy as much as we want. Yay. But what happens when we are in a big distributed application? Then all these services start getting very coupled very fast, because complexity is part of software development. If you leave it alone, it just gets very complex. So now our services are calling other services, and they're using APIs. So if our service is calling the other service, maybe it's waiting for the other service to respond. And now, for example, we have a customer that purchased an item, and the last step is to send an email. So in our last part of our process of doing the order registration, we ask the notification service, hey, can you send an email? And the notification service is down. Then our order process might be all broken, because one other service that is not really important is down. The customer doesn't care if it receives the email 5 minutes later when the notification service is up. Also, if we want to change one service or the other, then we need to go to all the other services that are using and change that API, because usually that's what happens. API are kind of attached to their service, even if we don't want to. So for that, solving a lot of those coupling issues that comes with large distributed applications, we end up building event-driven architectures. Event-driven architectures are based on the concept of an event. That is a signal that the system has changed. So now, instead of telling a service to, hey, can you send an email for me, and I wait for it, or if I do it more modernly, I'm asynchronously, but still I'm telling the service, so it's a one-to-one relationship I need to tell, and that couples these services together, I will just send an event, and the event will be observed by other services around. And they will say, hey, a customer just made an order. And the notification service says, OK, I will send an email. And then the fulfillment server will say, OK, I will process the order and start sending this package. And everybody does different things. So this is a very proactive thing. It's like when you're in a team and somebody says, hey, I just did this, and people start being very proactive and responsive. That's something we like. Because then all these services are very independent from each other. And they are not depending on waiting and being tied to. And this is what we call event choreography. We have these systems that are listening to the music, that are events, and are dancing to those beats, events, and doing different things. Nobody's telling them, you do this, you do that. There is no state that is managed. The only thing that is happening is the events. That's kind of the contract between the two different services, or two or more. When we talk about event-driven architectures, we talk about event producers and event consumers, usually our microservices, and the event broker that sits in the middle that decouples these ones. The cool thing of event brokers is that it brings more reliability, it's a hard word, to your systems. Why? Because by nature, events are asynchronous. So nobody's waiting for anybody. They are just sending an event, and the other ones are responding to it in an asynchronous manner. And this means that you can scale. So you might have a service that you can scale up very big, and if you are in a situation where those two microservices are very tight and coupled together, you need to scale both microservices in order to support the load. But in an event-driven architecture, you might not need to. You might add an event buffer in front of your other service and start taking the events as you can without really scaling the other service, and you can still respond if you don't need an immediate response. For example, in the case of a notification, your customer might not care that it receives the order confirmation 1 minute, 2 minutes, or 5 minutes later. So maybe your notification service doesn't need to scale if your order service does scale. So you can play a little bit with that. And if you have thought that you have never used any event-driven architectures, you're wrong. You have used them. Queues, everybody has used queues. Who has not used queues? Please don't raise your hand. But queues are a very happy pattern for developers. We love them. We put things in a queue, and then the different receivers start pulling things out from the queue and process all the messages that are being sent. It's a very normal pattern. Another one that is very common is the pub/sub pattern, where we have a publisher that publishes messages to a topic, and then all the different subscribers that are subscribed to that topic will receive all the messages. In here, the topic doesn't have a buffer, so the messages will come all the way to the subscribers. So if the subscribers cannot take the messages, you might need to have some magic in there. The magic is to put a queue in front of them, and then it's all under control. Then another common pattern is event streaming. And here you get a little bit of the two words, where you have a sender that is sending massive amount of messages to the event broker, that is the event stream service in there, and then all the receivers are receiving all the messages in their own time, because the event streaming will buffer for them, and then the receivers will be able to pull the messages. But I want to focus on the event bus, because I think the event bus pattern is the pattern that is really good for our problem, to decouple these microservices. We have producers, we have consumers, and we have an event bus sitting in the middle with different rules. The event bus pattern was very popular when the dinosaurs were roaming the streets in enterprises, when the amount of load that these applications didn't have was not high enough, that everything could be in one machine, before the cloud, before everything, that everything could be in a machine, and all the events were basically going to that machine, and then they were taken from there. But it got out of practice because that machine needed to scale so much, and it was the bottleneck for so many problems, that then we move into a more distributed with APIs and things like that. But now we're in the cloud. We don't have that bottleneck anymore, because that service can be a cloud service, and it can be maintained by the cloud. So you don't need to worry. The cloud will take care of making this high available, so you don't need to have a bottleneck, and everything is more distributed. And if you want to go one more step, and you don't trust that one region is good enough, you can do regional deployments and have multiple regions handling your events, because that's possible. So if you're in AWS, you can use Event Bridge, serverless event bus. You don't need to configure anything, just send your events and configure your rules, and boom, you're ready. How it works? Well, we have event sources. And this is the cool thing when you are in AWS and you take advantage of event-driven architectures, because we build our services to be event-driven. Most of AWS services will put messages to Event Bridge. So if you are already using operations and you're doing things with AWS infrastructure, you can check what is in your AWS event bus and see what is going on. Because you might notice that your security incidents might be there, some information from CloudTrail might be there, your EC2 might react to things that are in there. You can build a lot of automation with this. So most of AWS services will put messages like a new S3 file is uploaded, or a new item in Dynamo is created. They will put it in here. Then you can build your own custom events, so that's your applications. And then if you're working with SaaS applications, they can also create events into Event Bridge. Then you have different event buses, and this is an important concept. This is the highline, the highway where your events are going to move. The default one is where you will find your AWS events. The custom event bus is something you can define in order to put your applications. And then if you're using SaaS, you will find the SaaS event buses. Then we have the rules for each of these event bus. And then we have the targets. So for targets, we have around 20 services that can get invoked when an event happens: Lambda, containers, batch, messaging, SageMaker, CI/CD. And then we have one that I really like that is API destinations. That is basically a place where you can put an HTTP endpoint and you can send events to. So this is really cool to integrate to third parties. So how rules work? Very simple. The rules come from the event source, and then they go to a bus. And in the bus, the events will get analyzed by all the rules that you have defined in your bus. Some rules match, and when it matches, it goes to the target. So an event can trigger none, 1, 2, how many targets. So it becomes like herding cats. So this is how an event looks. It's a JSON. And in here, there is a couple of things that you need to have in mind. The source is the source of the event. It can be AWS dot and the name of the service. Or if it's a custom, like this one, it can be whatever you put in there. Here is my order microservice. Then the detail type, in the case of AWS services, will be something like object created, if it's an S3 that has put an object, or whatever is the action that it generated. Or it can be something that you write here, like order created. Then the detail is the payload, and the payload is whatever you want. And the cool thing is that the filtering will happen in any of these levels. So you can go as deep as you want in the filtering. For here, I just put a simple rule. But you can build rules that are extremely complex. And if you are into this, I recommend you to check the documentation for the rule filtering, because you can really get into very complex rules, and you can do whatever. In this case, we are just checking if the currency is Australian dollars or New Zealand dollars. And boom, it is. So this is a match, and this will trigger the service. A couple of good practices for building this type of event-driven applications with events, because there are some things that you need to know. It will give me a whole talk talking about this, but I want to address a couple of things. First, the amount of information you put in your events. Sparse events versus full state descriptions. This means events that don't talk too much versus events that talk too much, and everything in the middle. Events that talk too little, that has too little information, are great because, well, you have little information, and you are not leaking a lot of information around because you don't control where those events are going within your event bus. They can trigger whatever, and people can take them and do things with it. So it's good to be restrictive on the amount of information that you put in your events. But what will happen if you have too little information and downstream services need more information? They will start sending events back to your service, and you will flood your system with events and a lot of complexity. And you might even DDoS yourself. I have seen that. There's a lot of events coming, and services are getting crazy. So you need to be careful on how you're handling the amount of downstream services asking for more information. So put enough information. If you put too much information, then you are in the problem is that you cannot write a book. Most of these services has a limit on the payload. You have to know what is the limit in your case. And also, one important thing to address is that event schemas are the contract between your different services. So if you break that contract, sure, you can version and do all these kind of things, but we want to avoid complexity. So keeping the amount of data that is enough to work, that's great. So for example, you are building a service, and you put the birthday and the age in your event, because you just throw everything. Then that event is consumed by downstream services. And one service says, oh, I get in my event the age. Why I will calculate it myself? We are all lazy, so we will never calculate the age if it's there. So we use it. Then some developer comes into the first team and say, hey, we are sending the age. Let's remove that. They have the birthday. They can calculate it. And then 20 downstream services explode one day for no reason whatsoever. Well, they were depending on that. So the idea of event-driven architectures is that everybody is decoupled and they can work independently. But if you break the contract, you will be breaking someone's Friday afternoon. So be very mindful on what you put in your events. Also, security. Don't put too much private information in there, because these events are going into places that you don't know. And they might be handled by services that you are not kind of familiar with. So if you want to put personal information, you can encrypt that payload, and then you cannot match against that, but at least you can send it around. Another important concept, event uniqueness. Most of these services will send the event at least once. What that means that the event can come twice or more times. What that means that your user might get charged twice when they're using your e-commerce site. And what is worse PR than a user that is getting charged twice? A user that tweets about that. So you want to design your system for preventing that. How you do that? Using the concept of idempotency. One input, same output. But what that means, first event comes in, you do the payment, you output something. Now, same event comes in. What you do? Do you do the payment again? No, that will be terrible. Do I send an error, but then I send an error, and then the answer is return, don't do the payment, and return exactly what you have returned previously. It sounds weird, but that's how you should do it. And for that, you need to have a system that can handle the idempotency and can remember what is the right answer to send in every case. That will give me a whole different talk. Another important consideration is order. Most of these messaging things don't keep the order of the events. So if your application relies on events arriving in order, you need to be careful and you need to check the documentation. For example, use some service like SQS FIFO. For resiliency, please try to avoid that your applications really need to have things in order. It makes your heart and your head hurt, so try to design applications that can live without the order or event. It will make your life so much easier, and you can scale, and you can be more resilient. Challenge number 3, errors. How to handle errors. This looks lovely. We have now microservices that are decoupled. Everybody's talking to each other, happy, happy, shoy, shoy. But then errors start handling, and how we start handling those errors, how we keep track, how we unwind everything when my car rental doesn't work. Well, for that, we have the saga pattern. And basically, the saga pattern, what it says is that all operations that have side effects needs to have a compensating operation. So when you're designing this type of architectures, you need to think about that. We have the fantastic CRUD, create, read, update, delete. Everything by the R is a side effect operation. So you need to have a reverting operation for that. And that applies to choreography and orchestration. So in choreography, how it looks? Well, you have these 3 microservices, a new order comes in, it triggers an event, it sends it to the event bus, and it does its things. It then reserves an item so nobody can buy it. We have limited stock. Then we do the payment, shoy, shoy, happy, happy, boom. Customer doesn't have enough money, credit card number is wrong, so what do we do now? We revert all the operations, and this is built into our design. I have a totally different talk on where I talk about designing this type of applications. I will leave you a lot of links at the end of the presentation if you're interested on how you can build this type of things in a scalable and managed way. The same happens for the orchestration. This is the example of booking our holidays, where we book the flight, we book the hotel, we book the car, and if we cannot book the car, then things need to revert. For every operation, this is OK, color, but I cannot see it here. For each operation, there is a compensating operation when something goes wrong. And you need to think about the sad path, because your customers might face it. Let's be honest. Another question people ask, when to use each of them, choreography or orchestration. By this time, I'm pretty sure you all know when to use them. But just to clarify the concept, orchestration is about collaboration. Collaboration between bounded contexts, microservices. Producers and consumers are totally decoupled. They can scale, they can be deployed, they can be resilient together. Everything is easy to extend. You just listen to the events, and then you can build things around those new events that you're listening. Orchestration, communication inside a context, inside a bounded context, inside a microservice. You need to control the sequence, the order, the handling of the errors. You need to handle the retries. You are in control of the data sources. You want to audit every step of the way. So choreography between microservices, orchestrations inside microservices. That's kind of a good rule. So now you know a lot of things. Let's look at designing very briefly. So how you start? You think about business events. This is a business solution. It's a software architecture. We start from business problems. OK, these are our business events. The order is created. The order has been picked, blah, blah, blah. Then we start putting domains around these different events. And now we can go inside of one of these domains and start building a business process. We can start orchestrating what is the process that we need to do inside of our domain to produce this order-created event. And this is our state machine. Then that event that is produced outside of the domain is put in an event router, event bridge, for example. And then that can be taken by other domains to continue their life and do whatever they want. So this is more or less how we do it. Orchestration and choreography work together very nicely. And you can keep the control that you need, but also the decoupling that you need to work independently and grow your architectures. So how we do this in real life, we do it in AWS a lot. But I will show you one example of a project that we have built in my team. This is called the Serverless Espresso. That is a coffee shop that we put in many venues. We go to different conferences, and we take our coffee shop, and people can order a coffee in a serverless and event-driven way. So this is how it looks. This is reInvent last year. Basically, customers come in, and they don't need to talk to each other. So this is great. Didn't work that well in Italy. People were really wanted to talk to the baristas, but in the Nordics, people love it. You just scan the QR code, you can register, order a coffee, boom, you get an order number, it appears in the TV, and then the barista will get a notification on what code coffee you want, and it will start preparing it. And then when it's prepared, the barista will say, oh, this coffee is prepared, and all the systems will get updated with the state of the order, and you can pick it up. So no need to talk with anybody. So we love that. So this is all built by us. We have been, I don't know, in so many events since reInvent last year. That is our Vegas conference. We are going to be again this year. We have served 50,000 coffees by this time, served so many customers. So if you want to know more, just ask me. I have stickers around in my backpack for this. We use AWS services for doing that, so this is totally serverless. Everything is built as infrastructure as code. We have the repo. You can try it out. You can deploy it in your accounts if you want. But let's look at the architecture. So this is how it looks. It's a simple application that it has different layers. And the first layer is our front ends. And these are 3 different front ends: the phone, the display app, that is the TV, and the barista app, that is the one that the baristas can see which coffee they need to order. And if you see, they are connected by REST APIs and WebSockets. So here we are not talking about events. The events are for inside of our application. They are not to expose them, because APIs are pretty cool to talk to our front end. And if we want to have this event kind of asynchronous way, we use WebSockets, where we can just send updates to the front end without really needing to refresh the page. So that's why we have the WebSocket connection there. But we use events internally in our application, where all the different microservices talk to each other using events and event rules, and everything flows in an asynchronous way. For handling the state, we use the state machine, and here we will hold the whole life cycle of the coffee ordering. And every coffee has its own execution in the state machine. So basically, if the barista has capacity, if the store is open, how long each coffee takes, we will check for everything using the state machine. So basically, we can see the process from the state machine perspective, and by the time the QR code is in the TV, the state machine is already running. It's already verified that there is enough capacity, that the store is open. So we are ready that if the customers scan that QR code, then they will be able to process that order. So they scan the QR code with their mobile phones, they go to a browser, and the first thing they need to do is to validate. We ask them to put their phone number, so they can only get 1 coffee at a time. This is a demo, not a coffee shop. But if you were building this for your own application, you can add a login, you can add a payment wall, you can add whatever you need, because this is a web application. So now, basically, the customer can choose the drink. The menu is in Dynamo, so it's very easy to update. And basically, now they will get an order number. So they will push that, and now our state machine, the next state is generate order number, and it will return that 19 back to the customer. So now the barista will get a pop-up that says there is a coffee ready to be made, and it will start preparing the coffee. And when the coffee is ready, it will press a button that the coffee is ready, so now all the websites will update the screen, the display, and also the customer phone to say it's ready for collection, and things end. So you can see very clearly that the state machine and the different web applications are all connected, and this is done with events and WebSockets. If you ask how much this costs, this is running in the free tier. We can get around 1,000 coffees per day. And the only thing that it costs us is sending the SMS, because SMS are not free. So if you want to try this, I have the code. I can give it to you. Just ask for it later, and you can deploy it and play with it. We have even a workflow on state machines to learn how everything works. So let's up and have some questions. Microservices, agility and scalability, but debugging, and sometimes it gets very complicated to decouple, so we want to use event-driven architectures to coordinate our microservices. Event choreography is great to connect microservices, and we use this to decouple our applications. Adding new functionality is super easy with event-driven architectures, and this is something you need to have in mind, because nothing that you build today will stay like this today. You will need to add new features. A PM will come and say, hey, can you do this? And you're like, I need to touch so many things, but with listening to events, it becomes way easier. Design your event schema as a contract between services. Don't forget that events can come twice or more. Build for that. And be certain that most of the time, order is not warranty. And if you need order to be warranty, pick the right service. Orchestration is great to coordinate tasks within your microservices when you need to have order and you have to have a strict coordination between the different services. Don't forget to design for the SAT path using the Saga pattern. You always need to have a compensation operation for all your side effect operations. If not, something will explode in the face of your customers, and you don't want that. Combine them together. They work very nicely. And that's it. So there is a link here with a lot of information. There is in Spanish and in English. So if you're coming and you want to learn it in Spanish, you can go to this link. There is so much there. I have 400 videos in YouTube, and I think 200 are around this topic. So if you want to learn more, go for it. I show you how to build everything using infrastructure as code, so you will not visit the console. You will see how to build CI/CD pipelines for this, and we'll have a lot of fun. So that's it. Thank you. And this is the QR code for the same thing. So have a good day.
OK. Thank you for another excellent talk. Again, I'm going to try to group, because there are a number of questions. Some of them are more like comparing different AWS offerings around the same space.
I will be outside after this, so
let's try to use the time we have, and then Marcia will stay around if you want to grab her. She's an excellent person, aside from an excellent engineer, so she will attend you very well. So people are asking, like, OK, even though they are not the same products, right? But if, in a nutshell, if you had to compare, let's say, EventBridge versus Kinesis versus Kafka, right? Which is a question you probably get.
So Kinesis and Kafka are kind of the same type of offering, because we talk about event streaming. So Kinesis is the AWS offering. Kafka is an open source offering. They do more or less the same. My recommendation, if you come from a Kafka environment and you want to get into AWS, use Managed Kafka. If you're starting from scratch, use Kinesis. That will open more doors, because there is more integrations. But then they're both the same. EventBridge doesn't have the amount of scalability that Kinesis has, because it's different services. Kinesis is data streaming, event streaming, and EventBridge is an event bus. So event bus is to connect microservices together. Event streaming is to get a lot of events from outside, or if you have internally a lot of events. So there are two different use cases, so apply them to the right place. You can mix them. For example, if you need to ingest a lot of analytic data or a lot of event click data or whatever you're ingesting in bunches, use Kinesis or Kafka. And then inside your application, you can use EventBridge to connect those events. So I hope I answered the question.
Yeah. Then similar, but in another subset of offerings, because you have so many in AWS that it's hard to keep track. So you described the step functions, but then there's also Airflow, and that is also managed now by AWS. So I know they are not exactly the same either, but they kind of overlap. So I guess for the audience, when would you recommend one or another? Is there terms of scale, maybe?
I think if you're coming from the world of having that already implemented, the same with Kafka. Just migrate it, it's easier. If you want to take advantage of the whole offering, step functions is super flexible, and because we own everything, then we can make it grow and extend it. So again, it's always the same. If you want to come into AWS with whatever you have, we are welcoming you. But if you want to take advantage of the full offering, the native services are always more powerful.
OK, now let's switch a little bit in terms of questions around distributed services,
yes.
which is always complicated. So a number of people were plus one in this one. So in terms of anonymizing data, which is always a tricky point in many companies because of data compliance and developers having access, any recommendations you can give there? Or like
never put data into an event that should be anonymized, thinking that somebody down the stream will do it, because the moment you put an event with personal information into data stream, you lost control of it. So make sure that if you need to anonymize data, you do it in the source that the data is getting kind of processed. And if you need to pass data, encrypt it. EventBridge offers encryption for the events, so you can encrypt them, and nobody else, besides having those keys, will be able to access that data. So be very mindful, because it's like herding cats. The moment you put a data that is personal inside the event stream, you might lose control of it, and you don't want that. So comply to your GDPR regulations. Try not to put any data. If you need to anonymize, do it in the source that the data is coming from. So if you have an order where personal information is getting, be mindful of what you put into your event, and if you need to anonymize it there. Don't let it for later. Don't put it in your logs either.
OK, someone is asking, like, OK, if you are using SQS for passing messages, that one of the issues is that messages can get duplicated,
yes.
right, because of the nature. They're asking, because I don't know if this is covered, like, does EventBridge can help with the deduplication, or
no.
you need to write it yourself?
That's when you need to implement item potency. Yeah. So item potency, for example, if you're using Power Tools, that is one of our open source projects with Python, it comes with the item potency built in for event-driven applications. So it will create a Dynamo store, and then it will be checking and doing all that for you. You can build it yourself. I have one demo that I need to publish as a YouTube video on how you can do it yourself, but you need to handle that. And you need to make sure that that input and that output are always the same, because then if you will be flooding the system with events that are kind of broken, and events cannot arrive in order, so you might get an error before you get the success, and things will explode in your face. So item potency is very, very important.
Yeah, and yeah, let's do one more here, and then maybe some from the audience. So, so I guess the question they are asking is if there is a nice way to enforce contracts between microservices. You would say, yeah, let's do an API or protobuf, but they are all like quirky in a way. So, what's your take on that? Or
well, events are a good way to create contracts between services. They are a contract between services. And if you do it in an enterprise scale, you need to handle your events in an enterprise way, where you have an event repository where everybody can see the events and everybody can comply to those events. And there is a whole talk, I think my friend David Boyne has built around events and how to handle them, how to version them, like you do with APIs. And GraphQL or REST APIs have the same problem. So it's a whole thing that you need to manage on your enterprise level. But in general, what I recommend is to put the least amount of information that you can in the events, enough that you are not getting a lot of loops just to fulfill a request, but small enough that you can not need to manage a lot, and try not to version, because that adds more complexity into your applications. But at the end of the day, sometimes we need to version.
You said David, right? So maybe we can invite him.
He talks a lot about these things.
Yes, so there were more questions, but like we're running out of time. So maybe if someone wants to ask, otherwise Marcia will be around.
I will be outside now, so just grab me and I'm happy to chat.
OK. Well, OK, then thank you very much, Marcia.
Thank you.